So let's look at this one. Now the challenge with this one is first we need to notice that we have number bases. And remembering that with number bases we have to make the number bases the same. Now it's not immediately obvious maybe what the number base is. I mean, if you know your power times table, you will recognize 81 and 243, but you might not. So we need to come up with a strategy if you are faced with this problem. How do you work out what their number bases are? Well, to be honest, they're only ever going to ask you 2, 3. Bases are only going to either be 2, 3. They might ask you 4, they might ask you 5. 7 they may go to. Sorry, 6, 7, 8, 9, 10. They're not likely to ask you any more than that. And so from this list, we should be able to cross out the ones that don't apply and reduce the set of numbers that we have to look to, the possible bases. Well, first, 2 can't go because both of these are odd numbers, which knocks out 4, 6, 8, and obviously 10 can't go because you'd see 10, 100, and 1,000. So we've already reduced it to below half already. Next up, 5 can't go because it doesn't end in 5. Now, that leaves us with 3, 7, and 9. And the thing about 9 that you should note is that if 9 is a base, then so is 3. So 9 you can actually cross out as well. Okay, therefore we're only left with 3 and 7. So let's just start with 3 and walk our way through 3. So just walk our way up the list. So here we go. So let me write it down over here. So 3 to the power 1 equals 3. 3 to the power 2 equals 9. 3 to the power 3, I mean we're just tripling that. So that's 27. 3 to the power 4 equals 81. Ooh, there's a good point. We've got a 3. Now let's see what happens when we go 3 to the power 5. 3 to the power 5. We're just tripling this guy, and that goes to 243. So there we go. Sorry about that, as it not jumped off the bottom. We've found our two numbers. 3 to the power 4, 3 to the power 5. So we've found our new base. It's base 3. So again, let's rewrite these, and remembering that we wrap our new bases in brackets. So this is 3 to the power 4. Okay, and we still have this px over q minus 3 equals 3 to the power 5. Now in this case, we're not going to wrap it in a bracket because there's actually nothing else operating on it. Cool. Now let's just tidy this up a little bit. So we got 3 to the power 4, and I'm just going to leave it in its bracket for the moment. Yes, we will have to expand it out, but I'm not going to do that now. 3 to the power 5. So when we look at this, again, we've got the bases the same, and so since the bases are now the same, and they are in fact equal, that means that the powers must be equal. So we're now left with 4 times p of x all over q minus 3 equals 5, which actually is just a linear equation. And what they wanted us to do was to make p the subject of the formula. So I'm just going to skip through that pretty quickly. So I'm going to dig that p out. So I'm going to divide both sides by 4. So that'll be 5 over 4. So that's all gone brackets. And then I'm going to add, well, I've got a minus 3 there. So I'm going to add 3 to both sides. So I'm just going to put the plus 3 there. Okay, I've got a q there. So I need to multiply both sides by q. And I've got an x there, and I'm going to divide both sides by x. Now, to be fair, I've skipped through that pretty quickly. You don't need to, and if it's not the way that you wish to do it, then don't. Go through and do each step individually until you get there. But this is what we're looking at. I mean, we could tidy this up a little bit. So that's 5 over 4 plus 3. So what's that? 12 over 4 for that guy. So that's 17 over 4. And we've got a q on the top and an x on the bottom. P. Okay, cool. That's that one done. But the point being here is that our strategy, if we recognize that we have two bases that are completely different to each other. We generate our list and we're going to go look for them. Okay, and many of them will cancel each other out, will eliminate themselves very quickly. These are not even, so all the 2, 4, 6, 8, and 10 go. It doesn't end in a 5, so 5's gone. And 9, if it's going to be base 9, it can also be base 3. Okay, so we're down to 3 and 7. Okay, cool.